Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you for the revision video on Grade 11 Advanced Math Term 2 exam. In today's session, we will begin with the FRQ. In this video, I will be covering for you question 16 from your paper-based exam as per the end of term table 5. So let's get started. Please watch the video till the end and let me know in the comment section, did you find the video useful or which is the next video that you want from me? All the best. Okay, so let's start with learning objective 16. We are covering verifying trigonometric identities by transforming each side of an equation into the same form. Let's begin with 19 question. Now here there are two sides. One is the left hand side, one is the right hand side. Usually in these kind of questions, the answer is already given. We just need to show that both the sides are coming out to be the same thing. So let's solve the question. If you see the left hand side, we can use few trigonometric identities there. Let's do that. So we are going to convert everything into sine and cos. That's the best plan. So secant is the reciprocal of cos. So I'm going to write it as 1 over cos theta minus tan is the quotient of sine theta divided by cos theta. So what did I use? Let's write in bracket. Because it is FRQ, I want you to give me the steps and the identities that you have used. So this is the reciprocal identity that I use. And for tan theta, I use the quotient identity. So I'm going to write both of them in the brackets to let you know that this is what we have done here. Okay, now the denominators are same, so we can combine, take LCM. And because the same denominator is there, we can just combine the numerator together. So 1 and sine theta along with the negative are combined together. So this is what is the right side. Now if you see, we started with left and reached the right side. So that shows me that both are equal and hence we have verified the identities. Okay, so these both questions that you see in the presentation are from the lesson verifying trigonometric identities. These lessons are very easy because the answer is already given if you see in the question. So let's start with left hand side of this one, and again I'm going to use here trigonometric identities. So if I just let you know, I will change tan theta into sine and cos, remaining the denominator is already there. So let me put in place of tan theta sine theta over cos theta. So I've used the quotient identity. I'm going to put that in the bracket. So let's do it. So in the bracket, I will write that I use tan theta equal to sine theta over cos theta. So please, if these kind of questions come in FRQ, please make sure that you are writing all the steps nicely so that you would get full marks and that you are mentioning the trigonometric identities that you use. Now here if you see in the numerator, we just have one denominator cos theta, so I have to make them equal, and therefore I will multiply the numerator and denominator with the same thing, which is cos theta. And in that case, now I can take LCM and combine my common denominator. So in the next step, cos theta is the common denominator, and in the numerator I have cos theta plus sine theta. Now here, if you see, the denominator had sine theta plus cos theta, nothing was there, so over 1. So when I change this division into multiplication, I do keep change flip. So the next time when we move this to multiplication, the reciprocal will be done. So 1 over sine theta plus cos theta. Now I'm very sure you're able to notice that these two terms are same. So they're going to cancel, leaving us only with 1 over cos theta. So now we can use the reciprocal identity. This is secant theta, and that's what we wanted in the right side. So again, both sides are equal, and hence this trigonometric identity is verified. And before we close the question, let us mention here that which identity did we use? Yes, you're right, we use reciprocal, and the fact that secant theta is the reciprocal of cos theta. So this is how all your steps should be for FRQ. Let's do some more questions. So now I'll be solving 21 for you. So let's start with one side. I'm going to choose this time the right side, this one, and I'll try to make it equal to the left side. So let's do it. Tan theta plus cot theta. So as you would have understood by now, the trick is to convert everything into sine and cos. So let's do it. Tan is the quotient of sine theta over cos theta. Similarly, cot is the quotient of cos theta over sine theta. Now, before we go to the next step, we have to really mention which identity we use. So if you remember, we've used quotient identity, where I take tan theta to be sine over cos and cot theta to be cos over sine. Okay, so every time we are mentioning the identities. Now again, we do the same thing. The denominators are equal. We need to make them, sorry, the denominators are different. Here it is cos theta, here it is sine theta. So we will take the LCM and make them equal, which can be only done once we multiply. Now, if you see, in order to make the denominators equal, in order to take the LCM, we have to again, for the numerator, multiply sine theta with sine theta. That's going to land us with sine square, and cos theta with cos theta. That's going to land us with cos square. So now I'm quite sure that you're able to make out that we can apply the Pythagorean identity in the numerator, and it reduces to 1. So 1 over cos theta multiplied by sine theta. So let's mention the Pythagorean that we use sine square plus cos square equal to 1. This is important. Every time you need to mention which identity are you using. And now I'm just going to do one more step, which is to break this into two parts. One is this, one is this. So 1 over cos theta multiplied with 1 over sine theta is the same thing. And now I'm sure you know that the reciprocal of cos is secant and the reciprocal of sine is cosecant, and that is what you wanted on the left side. So if you see here, which identity did I use? Let's write. We used reciprocal identity, where I used the fact that secant theta is 1 over cos and cosecant theta is 1 over sine. Wonderful. So again, this is also verified. Let's do 22 now. So here I'm going to choose the right side again because this looks more complicated. Let's do little changes here on the right side. Now you must be wondering how I can go from the right side to the left side. Actually, you could have started with left also, but let me do this one. Now what I'm going to be doing, I want you to notice that on the left side there is plus sign. On the right side in the denominator there is minus, but if you see the terms are same. What do I mean by that? I mean that the first term here is also sine theta, here is also sine theta, here is cos theta, cos theta. So something is going to work for us in that manner. So I'm going to break open my 2 sine square theta as sine square theta plus sine square theta. So let's replace, and you will be just understanding in a minute why I'm doing that, because it's going to help me simplify and come to the left side. So this is my right side. I just open this to make it like sine square plus sine. Now what more can I do? Let's see. Yes, definitely you are right. I can use Pythagorean and convert into cos this part. So how will I use? Let's see. We know cos square theta is 1 minus sine square theta. But here you have sine square theta minus 1. So if I convert sine square theta minus 1, I have to take a negative outside. It's like changing the sign. So let me replace this value here. So the right hand side changes to sine square theta minus. Why minus? Because there's a negative here. So I will replace cos square. Okay. And the denominator is same. Now I'm sure you're able to make out that little bit of algebra is going to be helping us. And which identity I'm going to use? Difference of square. So let me just write this identity, then I will explain. So difference of square means if you have square term like here and they have a difference or negative sign, then you can use a plus b, a multiplied by b. So let's do that. One term is positive, second term is negative. Now let's see which term we can cancel. And it's quite easy to understand that the negative sine term is going to cancel, leaving us with sine theta plus cos theta, which is nothing but left hand side. So both right and left are equal, and again this is proved. Let's solve question number 23. So I'm going to start with the left side for this part, and let's see how we can reduce it to the right side. So let's start. So here it is like first term, second term, and the power whole square. So definitely I can use a little bit of algebra and expand using this identity. So when I do that, what I get, sine square theta plus cos square theta plus 2 sine theta cos theta. Okay, so I use algebra, and after using that I can use Pythagorean and combine my sine square theta plus cos square theta equal to 1. So let's see what this reduces to. So I've got 1 plus 2 sine theta cos theta. This is the value of the left side. Okay, let's see the right side also. This one. Now if I take the right side, it is 2 plus sec theta cosecant theta over sec theta cosecant theta. So it's best to convert everything into sine and cos. So I'm going to use reciprocal identity for secant and cosecant. Secant is the reciprocal of cos and cosecant is the reciprocal of sine. So let's plug in it here and see what we get. So 2 plus 1 over, now I'm directly just combining them and writing cos theta sine theta. Similarly here 1 over cos theta sine theta. Again we are going to do the same thing, take LCM and do keep change flip. So nothing is there means 2. So I'm going to make it numerator and denominator with the same term, and when we do that in the next step I'm going to get 2 cos theta sine theta plus 1 over cos theta sine theta, and here this is whole divided by cos theta sine theta. So let's do keep change flip. Now how I'm going to do, this is the numerator, this is the denominator. I change this division to multiplication. So let's see what happens. So this is the numerator, I just write it as it is, then I do the reciprocal of the second term because now I'm changing division to multiplication. So it's going to become cos theta sine theta over 1. So I'm hoping that you're able to make out that this term cancels, and what we are left is 1 plus 2 sine theta cos theta, which is same as the left hand side. So both sides, left and right, are equal to the same thing, which is 1 plus 2 sine theta cos theta, 1 plus 2 sine theta cos theta. So this way also we can verify. So hence verified. Okay. Let's do the 24th question. So here I'm going to start with left hand side. Let's take cos theta over 1 minus sine theta, and I'm going to just multiply the numerator and denominator with the conjugate. What is conjugate? See here the sign is negative, so the conjugate would be same terms with plus sign. Just take the opposite sign. So this is called kind of rationalization, where I'm multiplying the numerator and denominator with the conjugate or the term with the opposite sign. Now you must be wondering why I'm doing that, and it will be clear to you within a few minutes. So what we get, let's see. In the numerator, the two terms get multiplied, and in the denominator, just like the previous questions where we use the difference of squares, I'm going to combine the terms and use this identity. So how do you know you use this? You see opposite sign. See here it is 1 minus sine theta, here 1 plus sine theta. The first two terms are same, the second two terms are same. So when it is like opposite sign, I know I have to change it like this. So 1 square minus sine square. So let's see what we get. So in the numerator, I have cos theta multiplied with 1 plus sine theta. And in the denominator, now directly I'm applying Pythagorean. You know by Pythagorean that cos square is 1 minus sine square theta. So I'm going to replace this with cos square. Now it's quite easy to understand that 1 cos theta is going to cancel, but still I'm left with 1 cos theta in the denominator. And this is exactly what I wanted in my right side. So left hand side equal to right hand side, and hence we have verified. Before I go to the next question, I'd like to just remind you that these are my methods that I'm using. Obviously, there can be another ways also to solve these kind of questions. By that, what I mean that here, for example, for 24, I start with left side and I bring it equal to the right? You could have also started with the right side and bring it equal to the left. As long as your question is mathematically correct and the method that you have used has no errors, you will be given marks if your final answer is correct. So feel free to use any other method that suits you, provided it does not have any sort of mathematical errors. Okay, now we begin with question 25. For this one, I'm starting with the right side and I'm going to simplify and bring it closer to the left hand side. So again, this is a question similar to the previous one where you see conjugate. So definitely you are going to multiply the right side, numerator and denominator with the same term. Oh, sorry, it's cosecant plus 1. Oh, I will just change this. So it has to be the same term, cosecant theta, and because it is plus, so conjugate will have opposite sign minus. Now it's perfect. So again, I combine, use the identity of difference of squares in the denominator, a squared minus b square, and in the numerator I've got to multiply these terms. So let's do it. Now we can use in the denominator Pythagorean to simplify, and it would reduce my denominator and lead to some cancellation. So let's see what's cancelling. Oh yes, so we have got our left hand side. So now quickly we'll mention the identities that we used. Because it's FRQ, we need to show the steps. So the first identity I use is difference of squares, which I use actually, if you see carefully, in the denominator here. And then also I use the Pythagorean identity, 1 plus cot square theta is equal to cosecant square theta, which I use at this step. So I used in place of cosecant square theta minus 1 equal to cot square. Yeah, that completes question 25. Let's do 26. I start with right side. So cosecant theta minus sine theta. Let's see what we can use here. Yes, we can use the reciprocal identity. Cosecant is the reciprocal of sine. So I'm going to use that, and also I have to make the denominators equal. So to do that, I'll take LCM as sine theta, and the numerator will change to square theta. So let's write in brackets what all we used. First I used reciprocal for cosecant. Then I also used LCM, which can be written by this general rule. So we make the denominators equal and multiply the numerators. Wonderful. Now next is Pythagorean. I can reduce the numerator 1 minus sine square. By now you are very sure that it's going to be cos square. And now because I want to get to this part, I'm going to break this. So let's do it. So I will break it like this cos square in two parts, cos and cos. And with one part I can have my sine, with the another part just leave it like this. See, how do you know that you have to do these kind of changes? Because you already have the answer. You know you need to reach to this part. That means you want cos alone. So I keep one cos alone, and here you want cot, which is what? The quotient of cos over sine. So that's your kind of small tricks that you will use. And now we have reached to what we wanted, which is the left side. So yes, left and right side both are equal, and hence we have verified question 26 as well. Moving on, let me do now for you 27th, and this is quite easy to understand in the sense that the right side is just 1, so definitely we are going to start with left hand side. So let's see what we can do here, how we can simplify. So step 1 is quite easy. We want to convert everything to sine and cos, so the only way is to change tan. So I'm going to use tan theta equal to sine theta over cos theta. So here I'm applying the questioned identity, if you see, for tan, because I know that tan is the um, quotient or division of sine over cos. So let's replace sine over cos. And when we do that, things are going to reduce for us. Things are going to cancel as well. You can very well see. So cos gets cancelled. And I'm left with sine multiplied with sine, which is nothing but sine square. And then again, Pythagorean makes our life easy. And we are able to reach to the right side very, very quickly. So left and right side both are equal. And hence we have verified. So by now you've got a lot of practice for the trigonometric identities. You've got a lot of methods how you're going to verify. So I hope this video will make for you verification of trigonometric identities very, very simple. Before we move to the next FRQs, let's quickly close up these last two questions from this learning objective. So I'm going to start with 28 now, and I begin with the left hand side, this part. So I will now be little fast because you already know the trick. So I'm going to use for cosecant the reciprocal of sine, and I'm going to use for cot the quotient of cos over sine. Remember, there is square as well, and yes, inside we can take the denominator common, so I'm left with this thing. So let's also write, while we do this in brackets, what did we do? We use two identities, which is reciprocal for cosecant 1 over sine, and we also used quotient for cot, which is cos over sine. Writing these identities in brackets is extremely important, especially for FRQ, so that you don't lose marks. Now this square, I'm going to divide it in the numerator and denominator. So this is my numerator, and denominator becomes sine square. Now, before I go to the next step, I will use the fact that sine square theta is equal to 1 minus cosecant square theta, which is coming directly from your Pythagorean. So I'm going to replace everything in cos. See, the numerator already has cos term. Now the denominator is different, which is sine. So let's change it to cos. So I will also break my denominator because it is power 2 into 2 parts. Now let's see what the numerator is. 1 square minus cosecant square. So can I directly now just apply the difference of squares? And why I'm doing that? Because it will lead to some cancellations and it will lead us to the correct answer. So in the denominator, 1 is negative and 1 is positive. So by now you know which identity did I apply. A square minus b square is a plus b, a minus b. This identity I applied in the denominator. So this leads to cancellation, and it leads to our answer also, because now we have what we wanted on the right side. This. So left hand side equal to right hand side, hence verified. That completes question 28. Coming to question 29, I'm going to begin with the right side, which is cot square theta plus sine theta cosecant theta. And by now you know the trick. We have to convert everything to sine and cos. So let's put the value of cot. Cot is the quotient of cos over sine, not to forget the square. And then cosecant is the reciprocal of sine. When we do that, there are cancellations that happen. So here, if I open now, I get cosecant square over sine square plus 1. Now, we need to make denominators equal. So I'm going to multiply with sine square up, sine square down. Because now I have both the denominators same. So let's combine. So sine square theta is the new common denominator, and for numerator I have cosecant square plus sine square, which you already know is what value? Yes, you're right, Pythagorean, 1 over sine square. So this is your answer. The reciprocal of sine we all know is cosecant. So we have reached to our left hand side. Again, both sides are equal, and hence we have verified question 29 as well. Okay, let's solve question 30. I'm going to begin with the left side, so let's write it. Now, in the left side, I can use so many identities. I'm going to convert everything into sine and cos. So I will use the reciprocal identity for secant, and I will put in place of secant 1 over cos theta. Similarly, for cosecant, it is the reciprocal of sine. So I'm going to replace with 1 over sine theta. The same thing we do for the denominator as well. To simplify more, we will take the LCM for this numerator. To make the denominators equal, we will multiply sine theta cos theta together and then use the property for LCM. So the new numerator will become sine theta minus cos theta divided by cos theta multiplied by sine theta. So we multiply these two denominators in order to make them equal. Now in the denominator here we already have 1 over sine theta cos theta, so I will do keep change flip, change this division to multiplication and therefore take the reciprocal and it will become sine theta cos theta over 1. Now it's easy to identify that this term is going to cancel, leaving me with only the right side, which is sine theta minus cos theta. That's what we wanted. So therefore we have proved that both the sides are equal and hence we have verified the identity. So we move to the next question. Let's write in bracket what all identity I use. So basically I use reciprocal identity along with LCM. So I replaced secant theta with 1 over cos theta and I replaced cosecant theta with 1 over sine theta. So do mention the identities that you use. And now let's move to 31st question. Here I'm going to begin with the right side. In the right side, if you see, we have secant and tan. So I will just use here, this is pretty simple actually. Any side you start with, Pythagorean will help you. So let's recall Pythagorean. What is Pythagorean? Sine square plus cos square theta is 1. This is the Pythagorean that is applicable on the left side. For the right side, if you see, there is a Pythagorean which connects tan with secant, which is 1 plus tan square theta is equal to secant square theta. So if I just move the tan on the other side, then I know 1 is equal to secant square theta minus tan square. So the sign changes when we move this tan from the left to the right side. So this is the value. Now if you see, the left side is also 1, the right side is also 1. So it's so easy. Even if I start with right or left, doesn't really make a difference. So I'm starting here with the right side and I know this value is equal to 1. How I know? From this Pythagorean. So first I will put this thing in bracket. This big bracket tells you that these are the set of identities that we use for this question. And this value equal to 1 is equal to the left side. So very easy to verify that both sides, left and right, are equal and hence verified. Okay, that proves question 30. Now we are on the last question of this learning objective number 16. So let's complete this also. And I'm sure you are able to understand that out of the two sides, um, as I told you, you can choose any one. I'm choosing left side. So let's write it. And for the left side, there is only one identity I can apply, which is reciprocal for secant. So secant is the reciprocal of cos. So let's write 1 over cos theta minus cos theta over 1. So now we need to make denominators equal. And for doing that, I have to multiply up and down with cos theta second term. So now you see the denominator is the same. Let's combine cos theta and I'm left with 1 minus cos square theta in the numerator. Again, we'll use Pythagorean on the top, this one. So I will replace this with sine square theta over cos theta. I can also break this into two parts. Like there are two sines, so I will break them as sine theta multiplied by sine theta And there's a cos theta in the denominator, not to forget. Let's combine sine with cos. Quotient identity. Sine theta divided by cos theta is nothing but tan theta. So tan theta multiplied by sine theta, which is what we wanted. If you see the right side, so we start from left, we reach to the right. So therefore, both sides are equal and hence verified. Now one step which is remaining is the identity that we use. So let's write what all did we use. So in the first step, I replace secant with 1 over cos. So I use reciprocal identity. Please write them in brackets, whatever identities that you use. As I keep saying, for FRQ, you need to give me all the steps. Then we use at this step Pythagorean. We use sine square theta is minus cos square. Also, we use one more identity here where we replace tan theta. So this is quotient identity, that tan theta is equal to sine divided by cos. So I will put this in bracket and write quotient identity. So that completes question 32, and with that we have come to the end of learning objective 16. I hope this FRQ video you found useful to solve and verify the questions on trigonometry. That brings us to the end of today's session. I hope you liked the video and found it useful. Let me know in the comment section which video you want me to cover next. Like, share and subscribe to my channel because it serves as a motivation for me to make more and more videos for you. Don't forget to hit the bell icon so that you get the notification whenever I upload a new video for your revision for grade 11. That brings us to the end. This is Ms. Ruchika signing off from my channel Mathematics Made Easy and wishing you all the best for your coming exam. Bye students.